Hello everyone. Today I am going to talk about one of my project in machine learning class. This project called Fashion Recommender Engine. So overview is about this project. We're going to have 6 sections: introduction, data and analytics, data visualizations, machine learning model where I train my models, and evaluation matrix, result, and discussion. Coming to the introduction. Recommender systems are widely used today to personalize our user experience in the fashion industry. Users often face too many choices, which make it difficult to find items to match their styles and their taste. So in this project, I build and develop a fashion recommender systems using all the machine learning techniques and mathematics algorithm that suggest item based on our user preference and the past behavior, such as click and purchase. The goal is to help user find their own mask or their own style that they would buy in the future and save the less time. The problems. So the reason why I want to do this because I want to mimic the problem solving engine in the real world. Because nowadays users are struggling finding their personal styles, items, and needed recommendations. Imagine you go on online shopping and you couldn't find a single items, or maybe you like something and then you bought it before and now like you want something to match with your current outfit, but it takes you more time because you don't know what's the item called, you know where to what's the name of the item, and then what is the color, what match the item you want to buy. And so recommended system has to increase, not just increase the user experience but increase the user engagement that would help the business and build the worthiness, trustworthiness in the business. Go into the data sets and analysis. So the data set I'm getting to use today is the fashion product image data sets. I get it from Kaggle. And this data set contain about 44,400 images with over 40,000 image file of the description of the product. However, we only use a small dataset version of it. What do you mean by the small version dataset of it is to have the 44,000 image, but the resolution it will be worse because that's not like this is not the high resolutions. So like imagine the picture is like kind of a bit blurry. The product display name doesn't have any pack test, so go into the data processing. So I'm gonna do some data cleaning, but the product display name doesn't have any back text, so there's no cleaning on these things. But there's some missing value need to be cleaned and removed in the data set. So here are the missing value here: base color, seasons, years, USA, and product display names. Although these are the number of the missing value is not very big compared to how many data we have in datasets, so we would just simply remove every of the missing value in the dataset out. Here's the data visualizations. So I have more visualization in my report, but right here I'm gonna just choose like a two visualization, so that will make us understand more about the data sets. The first is top 15 popular item per taste. This is the visualization will show you what is the item, the bestseller item that customer usually buy. So we see that Topwell will have the range for every of the other products. Topwell is like shirt, crop top, t-shirt and everything else. And for the shoes, bag, bottom wears like you see, and the list of them is sandal, shoes, knees, heels, blah blah. And the next one is gender distribution. So I want to see in this data set how the gender spread over the product. I want to know like what gender will buy most of the products. And apparently the product for men is the most popular because there's a maybe there's not technically men buy this. There will be some women buying for their husbands, but mostly product for men is the best seller. So going to our main purpose of the project today is methodology. So I will build and develop four different recommended symptoms. There are four of them. So the first one is same category symptoms. And the second is cross category symptoms, CNS image based symptom, and then finally I will combine those three symptoms to create a weighted hybrid symptoms. So let me say more about each symptoms. So same category symptoms. Imagine you go into Amazon and you buy a pencil, and you will see a suggestion, say similar item that will recommend you the same pencil, but like from different brand, different color, different thingy, blah, blah. And then the cross category is imagine you buying short that you need something to match with the short. For example, a crop top, that the system will go into those category and choose some other item that inside the category and recommend it to you. So that would help you to complete your whole outfit. The third one is CNSMA-based systems. This system I will use a machine learning, deep learning neural network to analyze more about the image about the products to attract their style, their pattern, their light, their feature, some of like hidden patterns that the meta data of the product cannot give us. Finally, I will use a weighted hybrid system. So hybrid systems weighted is the way that you can give weight to each system. So for example, our mix CNN's image-based system will be the most weight because they will have the deep learning of it, and based on the evaluation matrix that I have for each symptoms, I would choose CNN would be have zero point 0.5 as a weight. For that is same category symptoms to recommend just a similar um, items. And for that, this cross category symptom would have zero point 0.2 of the weight. After create that systems, I will get evaluation matrix that will be precision, recall, and hit rate for my hybrid systems. Precision at 5 is, for example, out of the 5 systems, I recommend how many actually relevant. So the precision showed that 0.33. So that's about like system suggests 5 items and a user actually like 2 items in there. That were pretty good. And recall F5 is out of the items user likes. How many did I buy? This one is low because this one usually low because it's very like restricts to how many recommended items that we want to do, because we only do 5. So 5 doesn't cover like, because one customer bought like 400 items, over 400 items, and we just recommended 5, so it's hard to like match. But apparently we have like 0.45. That was pretty good. So that's mean like if using like 5 items, the symptom suggests correct about like 2 items they would like. Hit rate at 5. So hit rate at 5 will get like, did I get at least one correct recommended item out of 5? So my symptom suggests 5 items, and successfully that I have at least one items I suggest is correct, that measure like the user will buy in the future. So wrapping up the project representation today is I want a conclusions, a limitation, and future work I'm talking. So the conclusion is I noticed that hybrid model improve a lot of in performance, and I'm talking about like hybrid system usually give what the user want to buy, and hybrid system combine the strength of multiple systems. Limitations. It's because our data set is historical data set. Historical data set is like the data set you record the past behavior from the user. It doesn't continue record more behavior of the user like going on and on. So maybe there is some like old product, or maybe that's just like some of the user like very trendy, so they might not like the item that they used to buy, and they discover the news items that haven't been added to the data set. So this system will not cannot like variety, and then can change over time and catch up with the user's taste. The system 2 might have a very randomness algorithm because the way system 2 work is the rule-based systems. So rule-based system is I go to every of the master category and I choose random subcategory from that to suggest them the item format. And the last limitation from this system is about the low resolution image that couldn't capture enough feature because high resolution the neural network can go deep and deeper to see any of the pattern in their pixel. But because of this low resolution, we hardly find any like very correct and very like good patterns. So in my future work, I want to use this systems also, but I want to make it bigger by getting the bigger data set, getting the higher resolution, and then if I can, I would love to like connect to the API of some fashion product owner, and then I will use that to capture more styles and then more trendy styles. The second work I want to do is I would reduce randomness as much as possible. And the last one, yes, this is my I already said that I want a higher resolution for CNN's model. So that's it. That is my engines. This is the overview about the project I do, but the more detail and the work I've done is gonna be in my report. Thank you so much for listening.